Hello, today we are going to solve this today's daily lead code challenge minimum number of arrow to burst balloons. Here there are some spherical balloon tapped onto the flat wall and represented the XY plane. The balloons are represented as a 2D integer array points where point in is given as x start and x end denotes the balloon horizontal diameter stretches between x start and x end. So you do not know the exact y coordinate of the balloons. Okay. Arrows can be sort up directly vertically. So in the positive y direction from the different points along the x-axis. A balloon with the x start and x end is burst by an arrow shot at x if x start less than equal to x less than equal to x end. There is no limit to the number of arrow that can be shot. A shot arrow keep traveling by infinity, bursting any balloon in its path. Given the arrow points, return the minimum number of arrow that can must be shot to burst all the balloons. So here we are given something like starting point and ending point of all the balloons, and their y position is not known to the archer. So if he shot vertically upwards in any direction, so it will burst all the balloons which are been there. So we need to optimize the number of arrows shot into that direction to burst all the balloons. So here in the example number one, if we can see, if we look closely into these intervals 1 to 6 and 2 to 8, if I shot at if I shot at point 8, point 6, so this will burst both the balloons. And similarly in the case of 7, 12 and 10, 16, so it will be similarly, if I shot at 11, it will burst both the balloons. Similarly, we can see with the following example. So here the point length are given at 10 to the power 5. So I think if we iterate over all the points and find the count of arrows which can be shot, it would be optimal to do that. And in that case, time complexity would be also 10 to the power 5 and big of n. Let's see what we can do to optimize that. So let's see my approach, what I have done here. So in this question, if we sort at this merging points like at 6 and at point 10, we can burst all the balloons and minimum number of arrows sort which is 2 being used here. So if we try to merge these 2 points 1 8 and 7 16, so it we will get these sorting points and we will able to burst all the balloons here. But we can't merge further because we need to count the number of arrows which is being shot to the balloons, and arrows travels vertically. So rather than merging, we have to count number of arrows. So let's take the farthest right point we can sort from the maximum balloon to burst. For that, we have to sort on the basis of ending point, I think. Because if we sort at the rightmost point and keep counting the number of balloons which are being sorted and bursted by that arrow, that will serve our purpose. So let's take an example of this here. So if we sort these balloons on the basis of ending point, it will be 2 4 1 4 1 5 3 5. And if I take the first example 4, and if I sort at this position, so if I look into the every next balloons, so every next balloon's starting point is less than the arrow which I have sort there. So I think all the balloons which have a starting point less than the arrow which I have sort there, all will burst. So for this one arrow I can burst 1 2 3 4 balloons, and this balloon is left. So I will sort another arrow to burst this balloon. So answer will be 2 here in this case. So I think you understand the approach, and let's try to code it up in C++. So here I will sort my points in according to the ending points. I will use a comp function here. It will check the ending point. It will return the value which has been sorted, and return the and sort the point vector on the basis of ending point. Now I have two variables: my uh, number of arrows sort and the point at which I have sort last arrow. If the last arrow sorted is less than the point I and the starting point of endpoint, I will increase the number of arrows and also increase the last arrow point sorted. And I will take the rightmost. Let's try to run it and let's try to run it. So all test cases are passing. Let's try to submit it. So it got accepted. So this is the solution for today's minimum number of errors to burst all balloons. Thank you for watching.